and maybe ice if we get there. But for both of them, we need kind of a crystalline texture. And so
Has it
I'm
ever
going to put
happened to
some
you while having a
research
walk to just
here
turn around at see enough for
on
yet cells? Then a random color is
how to
assigned to
get our
each point, and
Voronoi
finally each
cells out
screen
of
pixel
the
takes the
non-random
color
genetic
of the
material.
nearest point. And that's it. If you're interested in a deeper explanation or how such thing is converted to material nodes, you can follow the video I already did about this. From now on, I'll assume you have a good understanding of what we're dealing with. Anyways, even from this simple explanation, where the issue lies can be easily understood. Since the decision of to which cell the pixel belongs to is made by using the Euclidean distance from a point, we can easily see why the distance gradient creates circles when thresholded. It would be handy to have instead a distance gradient that's linear from point to point, for every point in every neighbor cell for each cell. That will generate exactly the same cell shape, and the distance gradient will be exact to it. Essentially, the implementation of the Voronoi will stay the same. We're gonna add a fancier way of calculating the pixel point distance. So, let's understand how to create a normalized gradient from point to point first. Let's imagine that this is the current cell point, this is the neighbor cell point, and this is the pixel we are currently rendering. By subtracting from the current point position the neighbors, we get this vector. Now, since we want the gradient to be linear from point to point, it means that all the pixels sitting on an orthogonal line to this vector will have the same value. So, let's try to work out which value this pixel should have. Actually, which value would you intuitively assign to it? I'd say 0.5. If your guess is close to that, you probably had a very similar thought process to mine. I personally tried to eyeball at which point on the NC vector my pixel position would have hit it if translated along a line perpendicular to it. This exact operation translates to a dot product in math language. In fact, if we consider the pixel position to be another vector with the same origin of the other one, you can clearly see that this is a case of a vector projected on top of another one. But be careful, the dot product result is actually the length of the first vector times the second vector 1 times the cosine of the angle between the two. That means that doing the dot product as it is would give us a result way higher than what we need. To do a proper vector projection, we have to eliminate the length of the vector we are projecting on, which means that that length has to be equal to 1, which by extension means that such vector needs to be normalized first. Alright, this operation now will tell us how long is the projected vector. It isn't in 0-1 range. To make it so, we have to divide it once again by that vector length, which is amazing because that means that we are now avoiding the square root in the normalization, since now we are effectively dividing by the squared vector length. Let's now make a material function out of it, since we'll need to repeat this operation for each of the 8 neighbors of each cell. Now that we have it, we can use it to build our exact distance field, which will be another material function since we'll need to combine these distance fields with neighbors at the end. So remember, this whole function is basically replacing the basic distance we will normally calculate. What's happening is that I am evaluating the point-to-point gradient of the current cell. I'm evaluating the distance field of against the point of each of its neighbors. And to combine all these linear gradients to obtain the cell 1, we just need to keep for each pixel the maximum value. If you're wondering what's in the function that spits out the cell locations, here it is. It is a slight different implementation of what we built together in my first video about Voronoi. And now that we got all the distance fields, we carry on as usual, by mixing them all together by keeping per pixel the one with the smallest value. Hook everything up and we get this. It may seem a bit weird at first, but if we compare it with the usual Bernoulli gradient, we can clearly see that the cells still have exactly the same shape. And now let's go back to the reason why we did all of this. Will this work to mask out the edges of the cells? Definitely yes. But why stop here? Don't you think that this pattern would also benefit a lot if it had the possibility to smooth these shapes corners? Well, that's actually easier done than said, incredibly. We just have to go back in the distance gradient function we just created and swap all the max operation with a smooth max function. Look at that. I'd say that now the versatility of this pattern has extended quite dramatically. If you want to implement this last bit yourself too, you can follow this video I did about smooth minimum and
hang on. I might have a Voronoi distance. Kind of astounding to me that they don't just have this built in. That was a good video, but I don't want to do that whole process if I don't have to. Um, Asking Voronoi cell edges UE5. I kind of am astounded they don't have this. Mm. All right, so
We are the pioneers of American Wagyu. Almost 30 years ago, we bred our first Wagyu bull with our best cattle. Over the years, we've prided ourselves on delivering the best quality cuts to our customers all over the world. This isn't your standard beef you find in the meat aisle. This is American Wagyu beef. The kind
distance fields. if the resultant neighbor of the central one. Translates to repeating 8 more times this chunk of code we wrote, but each time adding an offset in the direction of the neighbor we want to sample. To add the possibility for
Let's check something. There may be a plugin we can get to avoid this. I'm not paying, though. Nope. Can't believe people were selling this. It's like literally MIT licensed. I can make that right now. Um, uh, UE5 material Voronoi distance field. Okay, I guess we gotta do this then.
When I start my edits, I like to look for a preset that has that vintage film look. Once I'm there, I'll make small.
has it ever happened to you? This vector point we are precising the distance from other material. Such vector needs to draw an effective operation for each of the 8 neighbors.
This is 2D as well, which is not ideal. Let's let me think about this. Feels like it would be so close, but it's just not. Okay, new idea. really don't have to make this big nasty function, especially since it's 2D only, and we're building our noise with 3D noise for the most part. Shitty. There we go. Okay. Sure. Let's do that. UE5 Voronoi crack text material. What the fuck? This is literally just the Voronoi texture added. Bruh, if you're just.
For work, play, and every day, upgrade with over 1 million parts and accessories and bring your truck to life. Real truck.
Hi, welcome again. Today we're going to talk about Unreal Engine. Some interesting uses, like if you're procedurally changing something. But here we don't have like a interesting shape. It's just like you can see the gradient over here, but it's not good enough for our case, and it doesn't have much variations in it. So that's why we have another sort of noise that's called fractal noise. So basically, with fractal noises, we get a single we want place, and you can easily see the representing textures and the we have this sometime. So if you use the texture base, and that's totally fine if you're using a
Uh, noise. Noise. Simplex. Start previewing. Hey, this might actually work. Like, it doesn't have to be a Voronoi based deal, but So what if we made our cracks with like simplex, right? And then we distorted them with Flournoy. So pull this down. We have some decent cracks, right? And then getting somewhere, I think. Something that might actually be somewhat passable. Another thing that I'd like to try is what if we did noise, vector noise. Mask. Okay. Okay. Now we're kind of getting somewhere. Kind of, sort of. We do have a clear seam here. So the first thing we got to do is come up with like a good cracked texture, cracked material. I'm just going to start from scratch here. All right, world position, object radius. I do this and then multiply by scalar. Could we mix and match, perhaps? And get something? It's just not the same. I can't believe there's no distance-based Flournoy just by default. It's kind of astounding. I don't. Doing a 3D implementation of what that guy did in 2D is probably just going to be more than I'm willing to do for something like this. So we got to come up with some alternative. Like, why do they give us this function, which is basically useless? What is our alpha channel coming out of this? Oh, is this the distance field? No, don't think so. Frustrating. Hello. This is what I got. It's very good. Do you really need somebody to do you really need to pay somebody $50 to run a distortion filter on a noise? God damn it. Do I really have to go implement this ridiculously complicated thing? I mean, whoever did this is not using like a crack pattern.
What a wonderful day!
There was a virus. It made apes smarter. And it almost...
Yo guys, what's up? This is Tom. When that is done, we need the mathematical x-axis to 0. Now that this is done, we can bring even more glow. So we grab the multiply node, duplicate it, default value goes into the B. Only the red channel goes into the add node now, because this is a normal texture. And the RGB from the normal texture goes into the normal. Now you can see how the normal map affects the material, and it looks like cooled down lava. Now we right click and search for multiply, and the pin from the add node goes into A, and the RGB pin from the fire goes into B another time, and this goes into emissive color. Now you can really see what's happening. So we got our lava material basically set up, but it's not glowing. So we press 1 on the keyboard, left click, and convert this constant to a parameter another time. And let's call this metallic. This goes into the metallic. Duplicate it by pressing Ctrl W, and let's call this roughness.
Interesting. So he's doing like
Fire tile texture here.
so that's definitely interesting. So we might be able to do something along the lines of this. So we're going to do noise, lerp. Height map. From grayscale. Oh, no. Material, it's my function. Material function call. Normal from. Breakfoot 3, or actually we can just component mask. Okay, that doesn't work. Bilala, scalar parameter. Uh, do, 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 5, 6. Mature minus. Fuck, we actually needed Voronoi. Mm-hmm. Well, how do they not have this? I'm just a little stunned. UE5 procedural lava material. Go. This looks good, but it's in Houdini. That's in Blender. We want something like this.
Guys, welcome back. Rocks from the lava. What we can do next is this nice separation of these two colors,
Problem is that those don't
1
want
and
some
minus
good
0.0 noise nodes. Then
okay. This is not going to be applicable. This looks good, but it's using textures almost certainly. Yeah, it is. Which, if we were just using textures, it would be relatively simple, because, like, we could go make a Voronoi distance field in another application and get our cracks. The problem is we need it to be procedural and tileable at planet scale. And texture's not going to do it for that. This is another one we're going to need, so we'll pull that up. But like, you see these cracks? He's just going to be using a baked texture for that, almost certainly. And that is not what we want. Now, something like this is something that we might be able to do.
welcome back, guys. So just very quickly, in my last tutorial, I made like this lava texture, that flowing lava part as well. So I just upgraded it, and you just plug it in, and you just compile it or like save it. So now we
It's all using fucking texture samples. We need to do it with just noise. So this is using the Voronoi grid. HLSL Voronoi Fractal Brax. Shader toy. Yeah, that's probably the way. Cracks. Okay. Well, this is hella simple, actually. It's just too complicated. I see. All right. We got a new HLSL project to do. All right. Thank you, Inigo Quiles. You are the man. Okay, perfect. Need this. Okay, so struct Illinois function. Boom. Okay. Awesome. All right, next. Illinois functions VF turn VF dot main image Hex cord. There's definitely going to be syntax errors here. We have to fix them one by one. But we did our quick and dirty conversion here, and then we'll do a custom function. Jesus Christ. Alright. Hold up. The fuck, man? I can't handle it. Okay, there. Jesus Christ. Okay. The fucking license is longer than the fucking material. Alright, so I'll put it here. Plug it in right here. Yep. I did in fact mean frack. Put 2p. Okay, yep. That makes sense. This is times call. Call equals mix is lerp. Okay. Okay. Oh shit. I think we're in business, sort of. Okay, it's a start. So next, where's my yellow color? So RG is yellow. That's wrong. Oh, come the fuck on, man. You kidding me? Call. Call. No, obviously it doesn't tile yet. It's also not fractal, so I'll have to figure that out. But it at least compiles. So let's get it copied back over here. DMR, VR. That ain't right. There it is. HLSL Smoothman. Is there a smooth min function in HLSL? Perfect. There we go. Pretty cool. Edge, smoothing, Skillala, and fine. If your Voronoi function can't do it, we'll just make one ourselves. Actually need this. Main image, front chord, float, edge smoothness, text chord, edge smoothing. No, we'll just do it as a, okay. Float, edge, smoothing. Theta, edge, smoothing equals edge. We're not out of the woods yet. We still have to convert this into a 3D function, which is probably going to be difficult. And also a fractal function. So, like, pick one. Do you want to make it fractal first, or do you want to make it 3D first, basically? And get rid of this. Okay. Back in business, and then this is going to be something about, so I had been using Twitch Studio, but I switched to OBS because Twitch Studio doesn't work anymore. And something about OBS makes the cursor not work over this window. It works in the material, but not over this window. You see this? Cursor just disappears. You have to guess where you're at. But at least now this should tile with the world position increasing. Let me divide this, do this. Yeah. Alright. This is what we were looking for earlier. We still got to do more work here, but it is a lot closer. What do these smooth step values do? Okay, that's what I thought. That's what I thought it might be. Okay, so we need two more values here. Float, min, edge, float, max, edge. 0.007. Something like that. Ha ha ha. Ha 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 ha. Okay. Yes, so that's our thickness. I'm gonna move this stuff to the bottom because it's annoying when you mouse over this thing to get that wall of text. Yeah, that's better. Okay, now we have edge smoothing. Edge min. Edge max. Scalar. Edge max. Edge min. Edge max. Oh my god, finally we were able to get the actual distance fields from this shit. It took long enough. We're also gonna want this value as well because this can form the height map. So like check this out. Vertex normal times the object radius times 0.05, allow 5% displacement, times vertex normal mask. There we go. And then over here, we're going to want to find high res um, okay. Oops. It is XY after all. Why am I not getting any displacement though? Um, do what? Maybe I was previewing. I was previewing the wrong spot. We could also just do it like this. Material function call. Normal from grayscale. Hey, all right, we got some cracks. So what we're gonna need to do, right? We're gonna need to output the the full range. So instead of this, we're gonna need to output like the full distance field and then do operations on it because we're gonna probably want to do two of these. One for like small cracks that are localized to the edges, and then one for the big cracks. We don't want to have to calculate this twice if we can help it. Well, we're gonna have to calculate it twice either way, but we don't want to have to calculate it three times for because this can form a mask. For example, what if we just output this value right here and we get rid of the emissive color for now? Okay, so we get this, right? So this is actually pretty useful. We could also do this. And this is also pretty useful. Now, this is clearly too much. Um, so, go back over here, do this. So, like, for example, we could use this to mask some noise, right? So, noise. And we kind of can already see where we're going with this, but if we take this, right, and then pow, and then we take this and pow, nope, wrong, power to give this some fall off, right, and then we multiply the two together, we should get like an edge noise pattern. Well, that didn't work. Let me see this again. So we could take this value here and then start previewing this node again. Start previewing this node again. can't I break the... Oh, I'm on the wrong key. Oopsie. Oopsie poopsie. Alright, start previewing. Alright, well, we at least got our, like, bare bones basic Voronoi crack texture working. Let's see, hang on. I gotta figure out how to use this too. I wish I knew how to pin elements so that they stay on top, but oh, whatever. Okay. Pretty cool. So, let's see. Let's see what coworker thinks about this. I have modified a Voronoi edge noise function. I pulled from shader DOI to use it in Unreal Engine 5. Currently, it is a 2D Voronoi noise function. How would I modify it to work? A 3D noise function that takes X instead of X. Here is the current function. Let's see if it managed to do it. So first, actually, let's copy this, paste it in here since everything is working. We don't want to lose it. Then, let's take this, come over here. New flow 3 MD. It's not gonna work like that. Well, that's pretty fucking cool. That's pretty freaking cool. Hell yeah. Well, that's shit. I usually, when I'm feeding this stuff to the AI, expect to have to do a bunch of fixing on it, but it got it pretty right, like right off the bat, which is pretty fucking cool. I'll take it. All right, so now we've got our 3D Voronoi cracking algorithm here. Already looking better. Hell yeah. So this is like one part of it, right? We'll have areas that are just pure liquid lava, but we need a surface texture for the areas that are like cooling. And that's what this is for. Pretty cool. And then we can actually do things like 2, 5, 2. This color's not super great. Oh yeah, there we go. Now we're talking. Well, this is super awesome progress in a short amount of time. So we basically have a non-tiling Voronoi crack function. This is so much better than trying to do it as like a material. Just have a fucking. So we got this working. So let's take this, paste it over here. Oops. I want to keep the MIT license stuff. Okay. Save it. Pretty fucking cool, actually. Pretty fucking nifty. Okay, so Yours too damn high. Roughness too low. Noise. Oh yeah, starting to come together. Probably the only major remaining problem is I'm not sure how well this is gonna hold up when you get up close to it. Although it looks not bad. Cool. That's freaking cool. Kind of kind of psyched about that. That's so cool. All right, so if you don't have a Voronoi function that works, just make your own, you know? Know what I'm saying? Do all kinds of stuff with this. Pink lava, green lava. Your problem is right now it's based on object radius and not a statically defined radius, which is why it's changing as we get closer to it. But, but, we can fix that pretty easily by providing a static radius. So instead of this, There we go. And this is what I was talking about with like at scale the normal transformation stuff doesn't really work super well, although we might test it. Let's drop in here. Because if we're far off the ground enough, or the water, it might be okay. Yeah, it might be okay. There's going to be world position offsets and all kinds of other stuff going into this. This is just a key component of making it look decent. And this would actually be like one order of magnitude smaller. Although the tiling seems to break down at that scale. Probably hitting like precision issues. So we can't actually do, well, what we could do is make this bigger. Keep in mind this material won't, this is just our like basically cooling lava material. So it won't be the entire surface. All right. This is some good progress. Like, this is definitely a useful thing to have around. We could also use this for, like, mud. You could use this for all kinds of shit. I'm going to go to sleep because it's late. So, yeah. Later.